Hello everybody, today I can find scale using scale is greater than or equal to the maximum divided by the number of boxes. This is a brand new lesson I just made for, as you can see the date in the bottom of the screen, 2021. This is a component within a bigger question, but it's something a lot of students have trouble with. So I want to just focus and make sure we understand how to create our scale when we're going to be graphing. So that way, when we get to these 6-point questions, we're comfortable with it. You're not going to get a question on the exam on the Regents that's going to look like these questions, but you're going to be doing this skill within bigger questions, and you'll see that when we get to the following words. So scale is going to be greater than or equal to the maximum value divided by the number of boxes, and we're going to do that separately for the x and for the y. So in this worksheet, I'm going to give you the tables, and then in the following sheet, I'm not gonna give you the tables. You're gonna have to come up with them yourself using the calculator. So I'm kind of leading you exactly what to do here. It's asking for the x max. So the x max is the largest x value, which in this case is 8. It's asking for the number of x boxes. So this is the graph for number 1, and I'm going to count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And while I'm here, I'm going to count the y boxes as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's not going to always be the same number of boxes. You just need to count depending on the graph they give you. In this particular example, there's 20 x boxes, there's 20 y boxes. I said x boxes, I'm so funny. So the x max is 8, the number of x boxes is 20. I'm going to also fill in the number of y boxes while I'm here. So the scale is greater than or equal to the max divided by the number of boxes. Now I'm going to go to my calculator, and I'm going to type in 8 divided by 20. I get 0.4. So my x scale is greater than or equal to 0.4. Now here's where you need to use your judgment. I can pick any value that's greater than or equal to 0.4. The closer it is to 0.4, the better it's going to look. However, I want to work with an easy number to make the problem easier for me. So in this case, it's pretty obvious to me what I'm going to do. I'm going to make the scale 0.5, because 0.5 is every other box. That's going to be a very easy scale to work with. It's very close to 0.4, so for me, it's a no-brainer there. Now, did you have to do 0.5? No, you could have picked 1. 1 wouldn't be a bad choice either, because it's not that much bigger than 0.4, and it is definitely very easy to work with. So there's not only one right answer. There is a wrong answer. It can't be less than 0.4, because then the values won't fit. Now I'm going to repeat that process for the y's. My y max I'm looking at now. Well, my y max, the largest y value, is 144. The number of boxes, again, is 20. It's not going to always be the same for the x and y, but it was here. So the scale is going to be greater than or equal to the max divided by the number of boxes. So the max for the y is 144. The number of boxes is 20. 144 divided by 20, 7.2. So my scale is greater than or equal to 7.2. So I can make it 7.2 or anything bigger than that. I want to weigh it being close to 7.2, but also an easy number to work with. So I'm going to go with 10. 10 is definitely an easy number to work with. It's not that much bigger than 7.2, so that's what I'm going to do. So now I'm just going to transfer onto my graph. It's kind of hard with all the different, with the scales and the table and the graph to fit it on one page. So I'm just going to kind of bring over the important information now. So my scale, my X scale is going to be 0.5. My Y scale is going to be 10. So let's write that here. My X scale is going to be 0.5. My Y scale is going to be 10. And then let's bring this table over. I don't think I need it to be this giant. And now I'm going to put this onto the grid. So let's start with my X. So if my X scale is 0.5, again, what that means is if each box is worth a half, then every other box is going to be worth 1. In general, I don't like to label every single box, because when I label every single box, it gets very messy. So in general, I like to label every other box. And it especially makes sense in this example since every other box is worth 1. So if every box is worth a half, every 2 boxes is worth 1. 6, 7, 8, 9, 10. Now my Y boxes are going to be worth 10, which means that every other box is going to be worth 20. 20, 40, 60, 80, 100. Again, every box is worth 10, but I'm labeling every other box, because when I try and label every single box, it gets messy. I'm not saying you can't do that, especially depending on your handwriting, but based on my handwriting, I like to label every other one. Now that I have that, I just need to plot the points. Now, they're not going to fall perfectly, and understand that that's okay. 0, 16, well, 16 is between 10 and 20, so I'm just going to put a dot between 10 and 20. 1, 72, that's a little bit bigger than 70, so I'm going to put it a little bit past 70. 2, 112 is a little bit past 110, so I'm going to put a dot a little bit past 110. You know, you won't be able to differentiate between 111 and 112 in the graph, for example, and that's fine. It just has to be, you know, in between the appropriate 2 boxes. 3, 136 is a little bit less than 140. 4, 144 is a little bit more than 140. 5, 136. So you can kind of like use this. This happens to be a parabola. You see it's kind of a mirror of itself. So you can kind of use that to help you. 6 is 112. It's a little bit more than 110. 7 is 72, a little bit more 70, and then 8 is 16. And now I connect it points with a curve. Now, in an actual question, it's going to give you a little bit more information, but if the graph hits the axes, we're not going to draw arrows. It's going to kind of die when it hits the axes, because a lot of these situations that they're going to be representing are going to be real life situations where you can't have negatives. But if it's not hitting an axis, then we're going to draw an arrow. In this case, both ends are hitting an axis, so I'm not going to draw any arrows. And if you notice, I did continue this thing into the axis because it would continue down. And that's it. So, what's the point here? You need to be able to find the scale. The scale, X and Y we're doing separately. It's the maximum value divided by the number of boxes. So the maximum value is literally just the biggest X value and the biggest Y value. The number of boxes, I literally counted on the graph how many boxes there were for the X and for the Ys. I did the max divided by the number of boxes. You'll usually get a decimal, and you want to pick a value that's greater than or equal to that number. The closer it is, the better the picture is going to look, but we want to choose a value that's going to be easy to work with. So I chose 0.5 for my X's because 0.5 is a very nice number to work with since every other box would be worth 1. And for my Y's, 10 is a nice number to work with. I could have worked with 8. You could have chose 8 instead of 10. That's fine. You could have chose 7.5. You could have chose 7.2. But if you choose 7.2, it's going to get really messy because it's hard to work with a number like 7.2 as opposed to 10. That's it. Let's skip number 2 for now. It's very much like number 1. And let's do number 3. So let's start with my X. My X max. My largest X value is 200. The number of boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And for the Y's, while I'm counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Again, it's not going to always be the same number of X boxes and Y boxes, and the scale does not need to be the same for the X's and for the Y's. So that was 30 X boxes and 17 Y boxes. So the X scale is going to be greater than or equal to the max divided by the number of boxes. So it's going to be greater than or equal to 200 divided by 30. Divided by 30. 6.6 repeated. So you want to choose a value that's close to 6.6 repeated, but easy to work with. Especially since my X's are going by tens, I think a scale of 10 would be great. I think it's going to really make things easier. It's a good, it's almost double the 6.6, but because it's going to make it so much easier to plot these points, I'm going to go with that. It's not wrong if you chose 7 or 8. It is wrong if you chose 6 because it has to be larger than that value. Why don't you, well, you know what? Let me just give you a little bit of a hint. Let's look at the Y's. My Y max is 1,000. Why don't you take about 45 seconds? You don't need to pause it. I'll just let the time go and try to come up with your Y scale. And again, it does not have to be the exact same as mine. So again, try and get the Y scale on your own. And again, it does not have to be the exact same as mine. The max divided by the number of boxes. 1,000 divided by 17, 58.8. So, I need to choose something that's greater than or equal to 58.8. I want it to be relatively close to it, easy to work with. I'm going to go with 60. So my X scale is 10, my Y scale is 60. So let's do that before we bring the table over. So if my X scale is 10, again, I like to label every other box just to make it a little bit neater. So if my X scale is 10, then this is going to be 20, 30, 40. Again, every box is worth 10. I'm just labeling every other box. Otherwise, these numbers would be on top of each other. I mean, as they are, they're on top of each other. So you could only imagine what it would look like if it wasn't. If you write really neat, you want to label every single box, then go for it. But I will not. My Y boxes are going to be 60. So every other box is going to be 120. Whoops. 240, 360, 480. Again, each box is worth 60, which means every other box is 120. So I'm labeling every other box and I'm going by 120s. And, you know, maybe I'll just do the last one, which would be 1020. Just that way I have a top in case I need that. All right, let's get my table. Now, there's a lot of points in this table. You don't have to plot every single point. We can just plot our key points. And that's all I'm going to do. So, well, I don't want to say just have to plot our key points. We want to make sure we plot our key points. But you don't have to plot every single point. There's a lot of points here. So I definitely want my, you know, my zeros are considered key points. My maximum value is considered a key point. As long as I have those points, I should be good. I'm not saying to just plot those three, but I think I'll plot every other point. I think I'll plot 0, 0. I think I'll plot 2360. So this is working out really nicely so far. That was on a nice corner. I'm going to plot 40, 640. So 640 would be a little bit less than 660. Why isn't it writing? Am I frozen? I might be frozen. Oh no, I might be really frozen. Oh, I think I'm unfrozen. Okay, my pen stopped working. So I'm going to have to use my finger, which should be okay. So 40, 640, this should be okay now. It's a little bit less than 660. 60, 840. 840. 80, 960. 100, 1000. That's going to be a little bit less than 1020. 120, 960. 140, 840. 140, 840. 160, 640. A little bit less than 660. 180, 360. And 200, 0. And then oh, now I'm really frozen. Let's try this again. The last point was 200, 0. Not working. Alright, I'm unfrozen, but my pencil isn't working. And there it is. So again, the main objective of this lesson is for you to get the scale down, to come up with the scale, label your axes, and then plot the points. So I'm just going to do one more with you. let's do number 7. Number 7 has 2 tables for 2 functions, which means I'm going to be graphing 2 things. Well, we're going to deal with it the same way, but when I come up with my max, I'm choosing the max from both tables. So my x max, my biggest x value, based on both tables, is 50. My y max, the biggest y value in both tables, is 50. So in this case, both the x max and the y max is 50, but I'm choosing my max. I'm choosing the absolute biggest x value I see out of both of them. I'm choosing the absolute biggest y value I see in both of them. Number of boxes, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, I'm running on my finger, so bear with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 12 for my x, 16 for my y. I want you to pause it. I want you to come up with a scale for your x and your y on your own. So please pause it and then unpause. For my x, again, it's going to be greater than or equal to the max divided by the number of boxes. I got 4.16 repeated. So what's greater than or equal to 4.16 repeated? Close to that value, but easy to work with. I think this one's a pretty obvious one. I think 5 is definitely the best choice. For the bottom one, for the y, I'm doing 50 divided by 16. That's going to give me 3.125. This is one where we may disagree. I'm looking at these. There's a lot of multiples of 5. I'm going to go with 5. Many of you might have gone with 4. Nothing wrong with going with 4, but I'm going to make each of them worth 5. So my x scale is 5. My y scale is 5. Let's bring over the table, or the table, should I say. Let's see if I can ungroup these. Nope, they're kind of stuck together, so that's going to be a little bit annoying. So I'm going to, well, I don't know what I'm going to do. I'm going to make them a lot smaller. That's what I'm going to do. And that should do the trick. So here's what I want you to do. Pause it. I want you to try and finish the problem on your own from here. Label your axes. I like to label every other one, so I'll just get you started. If this is 0, then this is going to be 10. Same thing here, since each box is worth 5. Label everything. Plot the points. Then you can unpause and see me go over it, or don't see me go over it and just check your answer on the key. And again, if you did a different scale than me, that's fine. It's just that your picture may look a little bit different, but there's nothing wrong with that. So again, try and finish this problem on your own from here. Pause it, and then when you're done, you can hit unpause. And you're going to do each one separately, 2 separate graphs. Okay, I'm going to start with f of x. Let's do that in blue. 0, comma, so, okay, let me first get my values. 20, 30, 40, 50, 60, 70, 80. So, and 20, 30. Again, each box is worth 5, but I'm labeling every other box, which would make every other box 10. 0, 50, 5, 40, 10, 30, 15, 20. You can kind of see this one's ending up to be a line. 20, 10, 25, 0. It hits the axes, both of them, so I'm not going to draw any arrows. I'm going to label that as f of x. Still purple. I'm going to now do g of x, 10, 0, 15, 5, 20, 10, 25, 15. We see this as another line. 30, 20. Looks like it has a slope of 1. 35, 25, 40, 30, 45, 35, 50, 40. Now, one end goes into the axis, the other one doesn't, so I'm going to put an arrow on this one since it is going forever. The other ones are getting cut off by the axis, so I wouldn't. Let's label that as g of x. So, again, the objective of this lesson is to come up with your scale. The scale is greater than or equal to the maximum value divided by the number of boxes. Do that separately for the x's and the y's. The maximum is literally the biggest value that you see for x and y in your tables, and the number of boxes, you're literally counting the number of boxes that are in the graph that's given to you. Once you divide them, you need to choose a number that's greater than or equal to that value. It should be close to it, but easy to work with. There's more than one correct answer. You kind of have to use your judgment. The closer it is, the better it's going to look, but we want it to be a number that's easy to work with, so we're less likely to make a mistake. Once you have that, label your axes, count everything out, plot your points, and you're done. So we need to be comfortable with this in order to do well with the next lesson. And the next lesson will be very common 6-point questions that are asked in the Regents. And if you know how to do this, then it's just kind of combining it with some other things. But this is really the meat of it. So that's why I wanted to do an extra lesson on this. So your classwork / homework is going to be to finish up scale. Scale, I can find scale using scale is greater than or equal to the maximum divided by the number of boxes. I hope everybody has a great day, and I hope you practice. Again, your classwork / homework is to finish scale.